This is chapter 3.1. We're starting quadratic functions, and specifically we're starting transformations of quadratic functions. So here's a little bit of vocabulary. A quadratic function is a non-linear function that can be written T-E-N in standard form f of x equals ax squared plus bx plus c, where a does not equal 0. And the reason a can't equal 0, if a does equal 0, well, this one goes away and then it becomes linear. All right? Everything else can equal 0. If all this can go away and it's still a quadratic function, but the x squared cannot go away. All right? Or it can be written in vertex form. Which is f of x equals a x, let's clean that up, x minus h quantity squared plus k. All right, we'll talk about h and k in a little bit in a minute. But again, this is where a cannot equal 0. And again, if a equals 0, well, 0 times anything means this entire piece goes away, which makes it a constant function, which means y equals just a constant number. All right, so it's no longer quadratic at all. All right, and just a couple of examples. You can do y equals 3x squared minus 5x plus 3. That will be a standard form, or what's called vertex form could be y equals negative 2x plus 3 squared minus 7. That would be a quadratic. That would be a vertex form. Okay? So again, I'll just label these real quick. This is standard form, ORM. This would be vertex form. And the reason it's called the vertex form is you can easily pull the vertex out of it. Once you know what you're looking for, you can pull the vertex out really quick. All right. A parabola is the U-shaped graph of does not start with F, of a quadratic function. And just a quick graph, if you have a graph that looks like this. Why did I write that upside down? Alright, this is that U-shaped form, and it can point up or it could point down. Alright, there's a lot of different ways it can happen. But those are both parabolas. Alright, we can actually even have a parabola that opens up sideways, which we will talk about later. Let me put that on a different graph so it doesn't freak everybody out. Although the fact that it's sideways may freak you out already. But you can have a parabola that opens up to the right or to the left. Okay, so all three of those are parabolas. All right, let's move on. All right, the vertex of a parabola is, let's stay consistent, is the highest point on a parabola that opens down, or the lowest point on a parabola that opens up. Alright, so for example, or you can think of it as Another way of thinking it is where the parabola changes direction. That's not a formal definition in any way, shape, or form, but it's a way of thinking about it. T-I-O-N. All right. So, for example, if I've got a graph that opens upwards like this, okay, the vertex is right here. Come on. Stop it. That would be the vertex. Okay, it's the lowest point on a graph that opens up. And you can also think of it this way. The graph is decreasing and then at that point the vertex is when it turns around, and now the graph is increasing. Same idea if it was opening downwards. If you had a graph that's opening like this, the vertex would be up here, alright, and it's increasing in that direction, it's decreasing in that direction. So it's where the graph turns around. And remember how I said earlier that it can be one that's sideways? Yeah, that's true. If you have a graph that's opening up to the left, okay, that would be where the vertex is right there, where it's changing. I mean, it's poorly drawn, but the graph is actually, technically, it's decreasing right there, and it's increasing right there. It's kind of a weird way of looking at it, but this is where the graph changes direction, so that would be the vertex. Let's take this down. Vertex. All right. Vertex form really doesn't need this much space to give it, but whatever. We've already spoken about it a little bit. A quadratic function written in the form Written in the form f of x equals a x minus h squared plus k, where a does not equal 0. And the reason, again, is if a was 0, if that was a 0, all of this would cancel out, and it would no longer be a quadratic function. That's why a cannot equal 0. Okay? So, for example, and this is why it's called vertex form. All right? If I have f of x equals, let's say 2x minus 3 squared plus 7, your h and your k are where your vertex is. Your vertex is at, I'll put it like this, h and k. Now, one thing, remember, everything in the parentheses is backwards. Or another way of thinking about it, you notice how the equation has that little negative right there? So when you pull out h, you have to flip it. So for this one, the vertex is at positive 3, 7. So if you were to graph this, you'd go over to 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and it'd be right there. And because the a value is positive, it's going to open up. And that's a really poorly drawn graph, but kind of give you an idea of where we're going with this. Okay? There we go, that's the vocab.